Hey guys, so this week we have the worksheet for 5:11 to 5:15. I'm going to do two problems from this worksheet for you as a demo to hopefully get you going. I've chosen problems 4 and 7. Number 7 is a new concept. I think that you guys will like it though. Okay, so I started with number 4. Notice I took the two equations that I'm given in the problem and wrote them next to each other instead of vertically because I want to work on them underneath. And what I'm going to do first is get them both into slope-intercept or y equals mx plus b form so that I can graph them. Okay, so I want the y to be in front, so the first thing I'm going to do is subtract 7x from both sides. And on this side, I'm left with 3y equals. On this side, make sure that you're not combining these. These do not combine with each other. This is an x in it, and this is a constant. So those do not combine. I saw a couple of people turn those in last week with them combined with each other, so make sure not to do that. The term with the x goes in the front, so negative 7x minus 12. You basically just write them next to each other. Okay, I'm almost done. I need to get y by itself, so that means I need to divide everything by 3 so that it's not 3y, it's just y. And I have y equals negative 7/3 x minus 4. Great. Okay, now this one we're going to follow exactly the same process. So I'm going to start with the x, minus x from both sides. I'm minusing it because this x is positive, so I want to do the opposite. Negative 3y equals negative x minus 12. Remember, the x goes in front and the constant goes there. Going to divide everything by negative 3. Okay. Now this, I'm really glad this came up. Notice I have negative x over negative 3. What I want you to do is write the 1 there that we don't normally write. And I want you guys to notice the negatives will cancel, and so this will become 1/3 x plus 4. I have the plus 4 because I have negative 12 and negative 3. I really want you to think about how that x is really 1x, and so I have 1 over 3 after I cancel out the two negatives to make a positive. Okay, so now we're going to graph these. Okay. So, graph them on the same axes, and the goal, remember, is to find the coordinate where they cross. So I'm going to start with negative 4 on that one. 1, 2, 3, 4. And the slope is negative 7/3. I'm going to go down 7, right 3. Okay, now remember that sometimes when we have slope that we count, it goes off the graph. So when I go down 7, 1, 2, 3, 4, 6, 7, 1, 2, 3, notice it's probably going off the graph on your page. Instead of going down 7, right 3, then what I'm going to do is the opposite of both. Up 7, left 3. Perfect. Okay. Now the second one, start by going up 4, and then the slope is 1/3, which means up 1, right 3. And notice I like to backtrack, and oh, I'm lucky, because when I backtracked I could see where the two lines crossed. Okay, so this is the point of intersection. 1, 2, 3, 1, 2, 3. So the final answer is -3, 3, which is this coordinate here, which is the point of intersection between the two lines. Okay, now let's do number 7. Number 7 is, interestingly enough, the same concept as number 4. We are going to still solve a system. We are just going to solve the system in a different way instead of graphing the two lines and find where they cross. Now you see number 7, if you're looking at your worksheet, is already set up in y equals mx plus b form, so it would be pretty easy to graph these two lines and see where they cross to solve the system. But we are going to do it algebraically. Okay. Equal values method is one of the best ways to solve a system if you can, because it is very clear and it doesn't require a large amount of graphing, or any graphing actually. So it's one of my favorites. What you want to do is notice that the first equation is equal to y and the second equation is equal to y. And if something is equal to the same thing, then they must be equal to each other. So what you do is you take both of the pieces that are equal to y and you equal them to each other. So notice that piece went there and that piece went there. They're both equal to y, so I made them equal to each other. And then you have an equation to solve, just like we've been working on all year. Okay, so the first thing I'm going to do is minus 3x from both sides. And then minus 3. And then divide by 2. So I got x equals -2. Okay, what I want you to know is that if I were to graph these two lines, they would cross. The coordinate would have -2 in here for x. Also, -2 is the x that works for both of these equations with a particular y. Okay, so this is only half done, because notice the answer here was xy coordinate, so we need to find y. Well, how I'm going to find y is by taking x and plugging it back into one of the two equations. It doesn't matter which one, I'm just going to plug it back into the first one. But because x and y need to work for both, it doesn't matter which one you plug it into. It's just you'll get the same answer either way. So y equals 3. Okay, so now x is -2 minus 1. Y equals -6 minus 1. Y equals -7. Okay, and your answer needs to look just like your answers for solving systems here. -2, -7, x, y. So what I want you to see is that we were able to find the coordinate where they cross without graphing. We found it algebraically using the equal values method. Put the two pieces that are equal to y equal to each other, solve for x, take x and plug it back into one of the equations. I did the first one, but you can choose either one to get y, and then write your answer like a coordinate. Great, everybody. Hope that you're having a good week. I'll talk to you soon.